I'm Fawad Khaliq, and I work for Plumgood Inc. And today we're going to talk about network monitoring and analytics in OpenStack. So before we start, a brief introduction about myself. I've been a member of OpenStack community for some time now. I'm also a developer and a contributor to the Neutron. And I also maintain the Plumgood Neutron plugin. So if any of you would like to contact me or get in touch with me, this is where my contact information is. So today's topic is about network virtualization and how we can monitor it and how we can add visibility to it, and we can find ways to debug if there's something going wrong. So just to give you some background, we have network virtualization, which is coming out of Neutron, and Neutron has done a great job in providing all sorts of network elements, which gives you these ways to connect your workloads or containers or VMs or bare metals that you can provide networking, from switches to routers to NATs and everything else, security policy and firewalls, the load balancer and DNS. So all of that is there. Now, the problem comes into the picture when you go to an operator says, I have my network up and running, something went wrong, I have no idea how to debug it. And this is where I'm going to touch upon some of the areas with some examples, how the feedback I've got from operators and the use of OpenStack and specifically networking, how they can actually solve this problem, and what is it OpenStack today as part of monitoring and metering, and what is it that should ideally be there and be introduced. So debugging and visibility is a must when we talk about networking. It's not something very trivial. It's not something people find fun to play with. They want to make sure that whatever they're playing with, they know what's going on. So there should be a way to troubleshoot comprehensively whatever is going on in the network, whatever topology that you have. There should be a way for cloud operators to actually automate or have tools that come and tell you something went wrong, or everything is good, green or red, whatever notification is there. And then you should have ways to actually connect to your workloads more than the way we do it today. Let's say there's an operator who cares about having a management plane into his or her virtual machines, and they don't want to use IPs to SSH into their workloads. They want to use UUIDs. They should be able to do it, and that's something we have seen as a request from some of the operators who would want to have these kind of tools to actually maintain their networking aspect. So as I mentioned, operators should be the focus over here. Operator is very important because they are the end consumers, they are the users of this cloud. And if I have to summarize a few things, the way we can actually provide this framework, which allows you to have debugging and monitoring of your networking infrastructure, it should be comprehensive. It should allow you to have real-time monitoring of your network infrastructure. You should have automation around it that, let's say your cloud is running, your packets are flowing, and if something went wrong, there should be an automated service which comes and notifies you that this something is wrong right now, you need to fix it. Or this is a bad state, it recovered after a while, and all of those things. And in the end, the most important part over here is we all are humans, and we don't want to create things for rocket scientists. We want to make sure that they are simple to use, and in the end, operators can use it in a way with small little things, like as easy as one button, start, stop, give me the report, things is good, green, red. So with that, I'm going to talk about some of the use cases which come around in this area, and this is out of maybe 50 different things which might be needed as part of OpenStack. But some of the use cases, let's say you have this notion of system alerts. So you're capable of a tool or a framework which allows you to automatically receive notifications from the entire cloud, all your tenants and their respective network elements, that everything is good or something is wrong. If something is wrong, what is wrong? To a point that they can even identify you that what exactly is the problem in the system at that point. Then let's say you have a network topology up and running, which you see over here in this diagram, that you have two servers, server 1 and server 2, and server 1 is running VM1 and server 2 is running VM2. These two servers are connected to a physical network, and then from a networking point of view, they're connected to a virtual network. And now what happens is that your VM1 starts stops talking to your VM2, and you need to figure out where is your packet being dropped. And for that, a utility or a way to be able to trace your packet, and you send from one side, it tells you, okay, this is the point in your network topology where your packet is dropped at that particular, or in that tenant on that topology. Then let's say we talk about the health report of your networking infrastructure. So cloud admins automatically receives notifications from all the relevant events, and that ends up speeding up the detection and recovery of the failure scenarios. And then one of the aspects over here is also the network statistics. So the stats are important one aspect that you have VMs, which are part of your network topology. These VMs are connected to networks, and then your networks are connected to, let's say, some L3 network elements, and they're connected to something else, and then a big network topology. And there are different operators who have stake in getting to know information about what workload and what port on what workload is using how many bandwidth or how many packets are going to that particular port. They might also be interested in a router port, how many packets are going over there. They might also be interested in what does my entire network look like, what kind of max it has learned, and things like that. So this comes as part of network statistics and as part of some of the tools or use cases that we have seen in the industry that should be introduced as part of the networking framework. So with that, we have a project in OpenStack. It has been there for a long time. It's called Ceilometer, which allows you to have this metering and alarming as a service. So the way it works is that you have a Ceilometer API, and this API allows you to have different type of meters for different systems. In this case, let's say you have a compute meter, or let's say you have a network meter, or you have a storage meter. And let's say for compute meters, you spin up virtual machines. And what you care about over here is that a tenant has n number of virtual machines, and what kind of profile all of them have, and are they exceeding my quota, or is this all fine? Then you might also want to care about, let's say you have a virtual machine which is using this much RAM, but you want to make sure it doesn't go beyond that. If it does, you need to raise an alarm. So that's where the compute meters come into the picture using Ceilometer API. Now I'll talk about storage. Similarly, some of the scenarios in storage allows you to offer, using Ceilometer API, what's going on in your storage infrastructure. Then the networking aspect comes into the picture, where you can define meters, what kind of stats are actually real-time happening in my system at this point. And Ceilometer today is doing a very basic implementation from a networking aspect. Perhaps maybe the focus has not been there. So what we have today in Ceilometer is that there are few drivers, networking drivers, as part of Ceilometer. And those drivers are capable of making calls to their backend implementation and find out from a networking aspect what exactly is going on. And in this case, let's say you create a network from Neutron, and then you create a port from Neutron, and then that port has some packets going through it in and out. So you would want to care about how many packets are received, how many packets are sent. You may also want to care about how many bytes are received, how many bytes are sent. Another scenario would be you created a router interface. You connected the router interface to two networks on each side, and then you want to see how much traffic is coming from each network to this router and going back. This allows you to analyze data in a way that you can actually infer a lot of good information out of it. Helps in debugging, helps in maintaining stats, helps in keeping the stats of the entire cloud, how much system has been utilized over its lifetime or over a past few weeks or month or year. And then the most important part over here is that it allows you to do it in an efficient way. And currently, most of the models over here are based on polling. So with that, I have a small demonstration that I want to do with Ceilometer with a network metering driver. In this case, it's a Plumget driver. So we have a setup with two nodes, a controller and compute, and the compute node. And then we are running Neutron here. And this is based on Kilo. So the Neutron plugin over here is Plumget. And the Ceilometer metering plugin over here is also Plumget. And the way we're going to do over here is that we will provision a network and a VM. and then we'll see a meter inside Ceilometer. It will start showing you stats of the packets received or sent. So with that, I'll go over the demonstration that I have. So as you see, I have the terminal session up and running here. In the terminal session, we have, let's go over the list of meters that are currently in Ceilometer. And we see that there are no meters running right now. Then we'll go over to the OpenStack dashboard, and we log in as admin. So inside OpenStack dashboard, I'm going to go and provision a network and a subnet, 100/24 with DHCP enabled. And now I'm going to go and provision an instance from Nova, which actually is going to create a port on Neutron connected to that network, and we should see stats coming into this port. So at this point, if I do Ceilometer meter list, I should be able to see that I have compute port receive packets, and I see a type and a unit and a resource ID, and a user ID and a project ID. And if I do Neutron port list, I should be able to map it to what resource ID maps to the Neutron port UUID, which is 7121, starts with 7121, and the same as resource ID. Now I'm going to go over the meter and see how the stats look like from this Ceilometer angle. So if I go over Ceilometer statistics -m, name of the meter, and with this, we should be able to see how the stats look like. So at this point, if you see, I have a sum of 8 packets, which actually were received onto the Nova Neutron port. And I'm going to go to the VM and start sending packets out, and we should see this number increase. So let's log into the VM, and let's ping the DHCP server, 1001. So with the ping going on, and if we go back to the terminal and look for stats again, we see that the sum has increased from 8 to 10, and that's something, a minimalistic, a very basic demo of how this is a starting point that we have to introduce in Ceilometer, and how the other use cases that we talked about have to be introduced in Ceilometer as well, or something else which allows you to monitor and debug and actually analyze your networking infrastructure, which is extremely important for your cloud operators. And I think I am done. Thank you.